Hi everyone, this video is going to walk you through the second lesson of Unit 4, which talks about how to graph lines by using and finding x and y intercepts. So as a quick review here, if you look at the top of the screen, x-intercept is where a line crosses the x-axis, while y-intercept is where the line crosses the y-axis. You can see on the graph sample above here, we've got ourselves a y-intercept at 0, -2, because that's where it crosses the y-axis. And we have an x-intercept at -3, 0. So that's a quick reminder as to what the intercepts are. What we're going to look at in this video are three things. We're going to look at how to find intercepts algebraically. We're then going to apply that to how to graph a line. And then we're going to take a look at a couple of word problems where we put both of those concepts together. So let's first talk about how we find intercepts algebraically. As you can see it towards the bottom, in order to find intercepts, if you want to find the x-intercept, plug in 0 for y. If you want to find the y-intercept, plug in 0 for x. So in number 1, it says find the x and y-intercepts of the equation provided. So let's go ahead and do that. So if I want to find the x-intercept, that means the y value has to be 0. So I'm going to go ahead and plug 0 into the equation. The beauty of plugging in zeros is that it's going to eliminate a lot of your math, because -6 times 0 goes away, becomes 0, cancels out. So I have 4x equals 32. Divide by 4, x is 8. What that means, the x-intercept, if I were to graph it, would be at the point 8, 0, because when x is 8, the y value that was plugged in was 0. Y-intercept is pretty much the same idea. The only difference is we plug in the 0 for x. So we're going to go ahead and do that. We're left with -6y equals 32. Now, this does not happen to divide evenly. That's not a big deal. More than likely, if I were to give you something like this to graph, it would probably come out to a nice whole number or integer of some sort. This comes out to 32 over -6, which is the same thing as -16 thirds. That means if the y value is -16 thirds is 0 is x, that means the ordered pair this represents is 0, -16 thirds. So algebraically, not a lot of complex math. It's just a matter of recognizing it's an intercept. Whatever intercept it's telling you to find, you plug in 0 for the opposing variable and just solve. So in terms of what this could look like if you ever see it on like an SAT or any other standardized test, maybe something like numbers 2 and 3. So number 2, I tell you the x-intercept of the graph of ax plus 3y equals 12 is 4. It wants to know what the value of a would be to complete the equation. Well, sometimes the intercepts are given as just one of the numbers. So if I tell you the x-intercept is 4, that's going to go in for x. Because of what we just established, if the x value of the x-intercept is 4, that means the y value has to be 0. So I'm going to go ahead and plug in the 4 for x and the 0 for y. So again, 3 times 0 cancels out. I'm left with 4a equals 12. Divide each side by 4. The a value would be 3. Number 3 is the exact same idea, except it's saying the y-intercept. So I give you the y-intercept of -16. That means the x value is 0. So again, I'm going to plug in the appropriate values. -b times -16 would come out to a positive 16b. Divide each side by 16. b would be 1. So just a little bit of algebra there, how to find the intercepts, how to plug them in, and you can see also it's okay to represent intercepts as either an ordered pair or simply just a number given. But again, if it's just the number given, just remember that the opposing variable would be a 0. Now let's take a look here at how we can use this to graph lines. Most of you probably like graphing lines by slope-intercept form. This is just another way that you have learned on how to graph lines that you can certainly use, and is sometimes beneficial depending on the way the problems are set up. So in order to graph by finding the intercepts, it's really simple. Find one of the intercepts, plot it. Then go find the other one, plot it. That'll give you 2 points. 2 points is technically enough to make yourself a line, and that can complete your graph. So let's go ahead in number 4, find the x-intercept. So if I want to find the x-intercept of number 4, that means we're plugging 0 in for y, which will give me 3x equals 12. X will be 4, which means I'm going to go to the x-axis and put a point on 4, 0. The y-intercept, do the same thing, except plug in the 0 for x. So it gets me 4y equals 12, y equals 3. Go to the point 0, comma 3 on the y-axis. And you can make yourself a line. Best that you can, but there's your graph. Do the same thing in number 5, same type of problem. So again, find the x-intercept. I'm going to plug in 0 for y. So that gives me 2x equals negative 10. That means the x-intercept would be at negative 5, comma 0. For my y-intercept, we're going to plug in 0 for x. So that gets me negative 5y equals negative 10. Don't make a mistake and forget a negative somewhere. That gets me a y value of 2. So at the point 0, comma 2, I can plot my y-intercept and make my line. So that's how you graph by finding intercepts. So it's using the same algebra that I emphasized on the previous slide. All we're doing here now is just actually plotting the points on the coordinate plane. The last thing that we're going to take a look at here is just combining those two elements and applying them to some word problems. So here in number 6, we got the Joe's Deli. You can order a small sub for $4, a large sub for $6. You have exactly $72 that you must spend the whole thing on subs. You got the equation given to you, which makes this even easier. You don't even need to write the equation. But what we're going to look at is what do the variables mean, find the intercepts, and we're going to graph and do some interpreting. So any good word problem, it's always helpful to know what the variables mean. So we can see the 4 is with the x. The 4 is the cost of a small sub. So it'll be $4 times x, the number of small subs. And then same thing with y. It's $6 per large sub. We don't know how many large subs we're getting. So that'd be the quantity of them. So y would be the number of large subs. So if you want to, we can label the axes. And then we'll go from there. So now we'll go find the intercepts and talk about what they represent. So we'll start with the x-intercept. So it'll be 4x plus 6 times 0 equals 72. The x-intercept would be at 18, comma 0. So that will just fit on here. It looks like I got it right in the corner, conveniently, an 18 by 18 grid. So what that represents, that 18 comma 0 would be 18 small subs without buying a single large sub. That's what that represents. It basically represents if you wanted to buy all smalls, how many could you get? The y-intercept would be the opposite. So the y-intercept would be at 12. So that would be the order pair 0, comma 12. And what that means is that's the number of large subs you could get without buying a single small. So basically it's the max out of the amount of larges you could get. So we'll plot that here. Just going to take a second to count this correctly. And there's my intercepts. So we're going to go ahead, draw my line. So we've labeled the axes, we've graphed it, we've interpreted what the intercepts mean. Now we're going to give 3 possibilities for the number of each size sub you could buy. So keeping in mind, it's a little bit different from an inequality. If this were an inequality problem, all you'd have to do is shade the graph the correct way, pull a bunch of ordered pairs, and you're fine. Since this is just an equation, it's a regular linear equation, you have to pull points that are exactly on your line that make sense. So we already know 2 easy points off the bat. 18, comma 0 and 0, comma 12. So again, what that means, with the 18, comma 0, that's 18 small, 0 large. 0, comma 12 would be 0 small, 12 large. We already know those work algebraically. So what we need to do is look at our graph and find another ordered pair that would work and also make sense in the context of the problem. Meaning both of my numbers of my ordered pair need to be whole numbers. I can't have fractions because I can't order half of a small sub or a third of a large or anything weird like that. So we need to pick points that make sense. This graph gives us several options. So you can see here the dots I'm putting on here. Now again, my line is not exactly perfect, but I can assure you these points are right. And the reason why I can assure that is because I can theoretically plug any of these ordered pairs in and get them to work in my equation. So for example, the first point I made was right here at what looks to be 3, 10. So if I do some quick mental math, 3 times 4 would be 12, because again, that's my x value. 10 times 6 is 60, because that's my y value. 12 plus 60 is 72. I know that point works because it algebraically checks out. So I can select that as my third combination. And with any of the other ordered pairs I pulled out, so I have 6, 8, let's see here, 9, 6, 12, 4, 15, 2. I have a bunch of different ordered pairs, all which will work to answer that question. So any of these, as long as you can plug them back in and get them to equal out and balance out in the equation, you're good to go. Easiest thing to do, though, is to use your intercepts to help answer that type of question, though. And then to find that extra combination, you can do some guess and check, or make sure you draw a nice accurate graph, and that'll help you solve it. The last problem here is the exact same idea. Birthday party, you're ordering pizza. Each cheese pizza costs $8. Pepperoni pizza costs $10. You have $80 you got to spend on the pizzas, and you've got your equation given to you. So, similar idea. X is associated with the $8 per cheese pizza, so the X would be the number of cheese pizzas. The Y is associated with the 10, which is the cost of the pepperoni pizza, so the Y is the number of pepperoni pizzas. So we'll find our intercepts, just like we did before. So our x-intercept, we'll plug into 0 for y. Our x-intercept is 10, 10 comma 0, which means that would be 10 cheese pizzas without buying a single pepperoni. So that'd be my max out there. My y-intercept would be, again, plug into 0 for x. My y-intercept would be 8, so the point 0, 8, meaning that's the maximum amount of pepperoni pizzas I can buy without buying a single cheese. So I'm going to go ahead quickly and plot my points. And also label my graph while I'm at it. So x was the number of cheese pizzas. And the y was my number of pepperoni pizzas. Since I haven't graphed, I'm going to go ahead and connect the dots. So again, it says the last part of this question here, give 3 possibilities for the number of each type. So we already established 10, 0 works. So again, 10 cheese, no pepperoni. We have 0, 8, which is 0 cheese, a pepperoni. So now we need to find a third combination based on our graph. So this one does not actually have that many options here to pull from. It only has one other option you can pull, and it's this point right here that I'm highlighting. It's at the point 5, 4. This is the only other whole numbered ordered pair that you can pull that works in this equation. So that would represent 5 cheese and 4 pepperoni. So that's how you go ahead and find intercepts, how you can use them to graph, and how we can apply them a little bit into word problems and reviewing all of those different skills there with the X and the Y intercepts. So your assignment, your grade for this is in IXL. You're going to stay in level K. Topic F18 is what you need to complete. And again, your target score is an 80. Keep in mind, this IXL and the IXL from the previous lesson are due by 9 a.m. of the first class next week. Please consult the calendar that's posted on Schoology to make sure you have your due dates in. If you have any questions or concerns, if you're having issues with the IXL, if you're struggling with any of this, please contact me, email me, Schoology, message me. If we need to set up a Zoom or any sort of video conference because you're really stuck, again, please contact me anytime that you need it. Thanks for watching, and we'll see you next time.